Hello, everybody. Welcome back. It's Mo again. Well, in this lecture, what we're going to be looking at is how can we configure fault tolerance for a router? Let me just show you first, without fault tolerance, how does the topology look like? For example, I'm going to get myself a router, let's say a 1941 router, all right? And let me actually get two switches. Here's one switch on the right side, one switch on the left side. And I'm just going to make it simple. I'm going to put a laptop here and I'm going to put an actual server right over here. Let me make the actual connections. So right now I only have one router. All right. So I'm going to connect from the router to the right side and also to the left side. So on the right side is gigabit 00. On the left side is gigabit 01. If I wanted to see the ports, which ones are actually connected, let me just show you. I could actually go at the top over here. Let me press escape, options, preferences, and I could say show port labels. You see this? I could see this is gigabit 00 and this is gigabit 01. So I'm going to go back to options, preferences, and get rid of the port labels. So it's more neater to look at the actual topology. So on the right side, I'm going to put 192.168.100.0/24. And on the left side is going to be 200.0/24. So I have two different networks. In other words, I have two different broadcast domains. This is one broadcast, and this one is another broadcast. So let me go to the actual command line itself. Call this router one, let's say. So I'm just going to give it an actual host name. Watch this. So host name is router one, and I'm going to put IPs on the actual interfaces. So the first one is going to be 100.254 space. I put a question mark. It wants to know the actual subnet mask. And of course, I have to enable the interface. Remember, router interfaces are always actually down, but switch interfaces are actually always up. So I'm going to do a no shut over here. Then I'm going to go to gigabit 01 and give this a different network, which is what? 200.254. Of course, no shut. So I have two different networks on my setup over here. And if I do a show IP route, I can actually see that I have 192.168, 100.0, and I also see 200.0. I can look at my routes as connected just like this, right? So I support two different networks. Now, this side is going to be 100.1. So watch this. So what I'm going to do is this is going to be 100.1, and the other side is going to be 200.1, which means I'm actually on different networks. So this one is going to be 100.1. And of course, the default gateway is what? 100.254, right? Which is the IP address of the router. And I don't actually need DNS. So DNS is not something that is actually required. And this one is going to be 200.1, all right? So two different networks. And I want to see just actual communication that is going on. How does the communication work from one side to another? See, right now, I only have one router, which means what is the path from here to here? It has to pass through what? Through the router itself. I only have one router, and this is R1. So can I reach from this side to this side? Well, if I put an actual packet over here and I put one over here, it says success. Well, you know what? Let me see if I could reach it from the command line, which is 200.1. So I could ping, right? 192.168.200.1. And look, I'm actually getting a reply. This server can be a web server, so I could actually open the web browser, right? And I'm going to put 200.1. So 192.168.200.1. And now I could actually reach it. If I want to check the path that it takes to reach from this side to this side, what do I do? Tracer. All right. So watch this. From the command prompt, I could do tracer space 192.168.200.1. Now, this actually tells me the path that it takes from source to destination. So the first thing that it actually goes through is 100.254, which is this interface right over here. And then from this side, if I go to this side, it's going to go through what? 200.254. So I'm going to open the command prompt and I'm going to say same thing. Tracer 192.168.100.1, and let me see the path that it takes. And it's actually going through 200.254. I mean, I could do this in actual live simulation. Watch this. This is what I love about the Cisco Packet Tracer. So if I go ahead open this and I do, you know what? Let me do a trace search and let me go back right over here and play it. And look what it tells me. It's going to go through the switch, then it's going to go through the router, right? It's going to reach the destination because there's only one route to reach from source to destination. So watch this. So now it's going to be reaching. So this is like if it's a broadcast, it's actually going to stop it. Then it's going to reach the server. The problem that I have over here is I only have one router, which means if this one fails, there's no way this laptop can reach the server. And guess what, folks? This is something that every organization has. So what I want to look into, how can I have a backup router? Words, if one router actually fails, right? How can the actual second one, which is the standby, can I kick in? And that's what I want to actually see in our next lecture. So this is what I want to actually show you at the beginning. Without fault tolerance, right? It's going to be like the way it is. There's only one path that is going to go through to reach the actual destination. In our next lecture, I'm going to have two routers, and I'm not going to configure HSRP, and we'll see what that is and we'll see what happens without it. All right. So we'll see you folks in our next lecture. Bye now. Everybody, welcome back. It's Mo again. Well, in this lecture, we're going to do is we're going to be looking at two routers. Watch this. Let me just open a new topology. So I'm going to be putting two routers this time, one right over here, one right over here. So watch this. So I'm going to go back here and make this as router one, right? And this one as router two. And then I'm going to be putting two switches. So one switch over here and one switch here. Remember our previous example only had one router, all right? So look at this. I'm going to be putting a laptop here and I'm going to put an actual server right over here. And let me make the actual connections. So from router one, gigabit 00 is going to be hooked up to the switch here. And also this router, gigabit 00, is going to be hooked up right over here. This side is gigabit 01 right over here, and this side is gigabit 01 right over here. And then the laptop is hooked up to the switch, and the server is hooked up to the switch, just like this. So this side is going to be one network, which is 192.168.100.0/24. And the left-hand side is going to be what? 200.0/24. Watch this. So I have two different networks. All right. So I got 100.0 and I got 200.0. Well, I'm going to make this one, I'm going to put a note and make this one as .254 and this one is also .254. This one is going to be 253, and this one's going to be .253, just like that. All right, just like this. So I'm going to go to my actual router one, CLI. So the first thing I want to do is I want to change the host name of the router, which is R1. And then I'm going to go to interface gigabit 0/0 IP address is 100.254 space the default mask. Then I'm gonna do a no shut. All right. And then I'm gonna actually go to what? To my gigabit 01, right? And give it an IP address as 200.254 and do a no shut. So of course I'm hitting the up arrow here to get the last commands that I did. So I just put IPs over here. Watch this. Let me save my configuration. So when I do a show IP route connected, I want to see what I'm connected to. And I can see over here that I have the 100 and the 200, right? So I have two different networks. Now this side is going to be R what? R2. So R2 itself, let me go to the CLI. I'm going to change the host name, right? So watch this. Host name R2. And then I'm going to go to interface gigabit 00, which is the one on the right side, right? And I'm going to give it an IP address as what? 100.253. Watch this. Face the default mask. And then no shut. And then I'm going to go ahead to interface gigabit 0/1 arrow a few times, 200.253, and what? No shut. See that? Just like this. And let me save my configuration. And when I do show IP route connected, I can see that I support the 100 and the 200. So I support both, right? So this side is the 100 and this side is a 200. What's the difference between this topology and the previous topology? Well, this topology has another router. The previous topology only has one router, only one path to go through. So watch this. I'm going to give this a number. Let's say 100 dot 100. Okay, I'm not putting a default gateway yet. And let's say this one is 200 dot 100. All right, watch this, just like this. So I'm going to go from here to here, right? So can I connect? Let me try and see first. So if I open the command prompt, can I ping 200 dot 100? It's not going to work. Remember, this one is 200, not the 100. The reason why, there's no default gateway. I'm not telling it to pass through a router if it wants to reach a different network. All right. So watch this. It's actually failing. I mean, when something fails, folks, let me do a control C. I like to do a tracer, which is 200.100. Let me see where it's failing. It's failing from the beginning. See that? It's failing from the beginning. It's not passing through the router. All right. Which means, okay, well, I'm not looking for HSRP or other protocols for actual fault tolerance. I'm going to do manual configuration, which is not recommended. But let me show you how it works without the actual protocol itself that does the work for us. Watch this. So this side is on the right side is 254, and on the left side is 254. Let's say I want to use this router right now. So I would go ahead and put the default gateway as 100.254. See that? And then I would go to my actual server, watch this, and put 100.254.254. Now I want to see if I could reach. Go back to the command prompt. First of all, can I ping? Yes, I could reach my server because going through a router. Because if I'm trying to reach a different network, I have to have a default gateway. But if I try to tracer, there you go. It's passing through the top router, 100.254 to reach here. And same thing, if I open, let's say, the web browser, I want to connect to the server itself, which is 200.100. Watch this. I could reach it. If I want to do some simulation mode, and I would open this, and let me go ahead to the command prompt and do an actual what? Tracer and play. Look what it does. It's going to pass through the top router because that's actually the default gateway. All right. And then it's going to continue to the destination. So, of course, the broadcast doesn't actually what? Pass through. But as you see, it didn't go through the bottom router. It's going to attempt to go through where? The top router itself. ICMP is a reply from the ping itself. So if I go back to real time and I open this and I say, you know what? What if I try to ping? Go to simulation and try and ping, right? And then click on the play. Watch this. So let's take a look and see. It's not going to pass through the bottom router because I told it manually to connect through the top router, which is R1. And then it's going to reach here. Then it's going to go back to the left-hand side, as you see. So this is what I could do without an actual protocol. Well, your question is, what if this router crashes? Does this switch automatically to router 2? Of course not. You see, that's why those protocols kick in. So watch this right now. Let's say something is wrong this side. I know that when I do a tracer, it's going to go through 100.254, which is this one, right? This is 100.254. Now, let's say something is wrong with this side. So I'm going to do X, remove this. And now if I try to go through 100 to 200.100, it's going to fail. Watch this. It's not going to switch to the other router because there's no protocol configured such as HSRP. You have to do manual configuration. Watch this. See, it's failing. So I have to, this one is what? 100.253. So I have to go back to the machine or change something under DHCP where now the default gateway for my clients is 100.253, and this doesn't make sense. Then I have to come back over here and change this to what? This should be 200 actually, right? 200 dot what? 253, not 254. It doesn't have to pass through that, right? So watch this right now. So if I connect now and I do the tracer again, watch this. So this time it's actually going to work. Let me stop this by doing Control C. And now it's working. It's going through 100.253, which is the bottom router. You see this? Let's give it a moment. Let's give it a moment. Let me try it again. And also, this server should be able to reach the laptop, which is what? 100.100. So if I go to command prompt and I say tracer 100.100, right? It should go through the bottom router itself because I did manual configuration. Maybe the first one is going to fail, but let's take a look and see. Give it a moment. Let's see the numbers here, 100.253, 200.253. This looks good. It looks like it's still failing, right? Let me take a look and see what's happening over here. Let me close this out. IP 100.253, 100.100. This is good. And let me see this one. Let me just check the number again. 200.100. Oh, I put 220. So 200, there you go. 200.253. You see that? Troubleshooting. And back to the command prompt. And look, immediately when I fix this, like, hello, I can go through what? 100.253. And this server will say, yes, I can go through 200.253. See that? So I could reach. But is this something that you'll ever do? Of course not. It doesn't make sense to do manual. Look what kind of mistakes we could make, right? It doesn't make sense to do manual changes. That's why in our next lecture, I'm going to be introducing HSRP, and that's going to do the work for us. I don't have to go to machines and tell my employees, you know what? Can you folks restart because you need to get a new IP address from the DHCP server? No, no, we don't need to do that. We need to configure HSRP. All right. So we'll see you folks in our next lecture. Bye now. Hello, everybody. Welcome back. It's Mo again. Well, in this lecture, what we're going to be looking at is how can we configure HSRP. For our previous setup, we actually had to change the IP address of the default gateway manually. So I'm pressing the control key so I could choose more than one device. There we go. Let me just increase the size, right? Let me drag these right over here. And then I'm going to do the same thing with two switches. Control 2960, one on this side, one on that side. And I'm going to get a laptop over here and let's say a server right over here. Let me make the actual connections. So first of all, I'm going to connect my gigabit 00 to the switch, this side, and gigabit 01 over here. And I'm going to do the same thing on this router, gigabit 00 to over here, and gigabit 01 to the left side. So gigabit 00 is on the right side, gigabit 01 is on the left side. I press escape to get rid of the cable. This router is going to be called router 1, and this router is going to be called what? Router 2. This side of the network is going to be my 192.168.100.0/24. All right. And this side is going to be 192.168.200.0/24. Just like that. So I have two different sides over here. I'm going to give this one as an IP address as 100.254. And this one is going to be 200.254. This side is going to be 100.253, and this side is going to be 200.253. See, these are the IPs of the interfaces. Now, if I want to make sure what interface they are, I could go to options, preferences, and say show port labels. All right. And look, I can see the actual ports. All right. So let me actually get rid of this preferences and remove the port labels. And of course, let me make a connection from the laptop to the switch and from the server to the switch. Let me first come up with the names and put actual IP addresses on the interfaces. So let me say no here. hostname R1, interface gigabit 0/0, IP address is 100.254 space the default subnet mask. And then I do no shut. All right. And over here is gigabit 0/1. This one will be 200.254. All right. And I'm going to do also what? No shut. And I like to save my configuration, do WR. Then I go to this router, which is my router 2, which is going to be the standby router, which is the backup router. All right. So watch this, folks. Host name R2, and then I do interface gigabit 0/0. IP address is 100.253, right? 253 space the default mask. And then no shut. And then I do gigabit 0/1 and I do IP address, what, 200.253, and I do no shut. See that? And I like to save my configuration through WR. I'm not putting IPs here. I'm not putting IPs over here. I need to configure HSRP. Now, HSRP, which is hot standby routing protocol, which means one router is going to be the active router and the other router is going to be the standby router. So I have one active and one standby. HSRP only works on Cisco products. There's also VRRP, Virtual Routing Redundancy Protocol, that works on Cisco and non-Cisco. And then there's GLBP, Gateway Load Balancing, Gateway Load Balancing Protocol. That actually means I could have more than one active router, which is good for what performance, right? Where the HSRP only one can be up and running, and the other one is an actual backup. So let's see how we can configure HSRP, which means I have to put a virtual IP for this side on both routers, and I have to put a virtual IP on this side for both of the routers. So the virtual IP is either going to represent router 1 or router 2. So I'm going to go to router 1. Watch this. So I'm going to go first of all to interface gigabit 0/0. Let me ask for help. Where can I see the HSRP commands using the standby? Okay, so let me type standby and ask for help. I have to come up with a group number. I want to match the network, which is 100 space question mark. And look at this. Let me come up with a virtual IP address, and I'm going to say this one is going to be 192.168.100 dot, let's say 1. All right. Then I need to go to gigabit 0/1 and do the same command, but this is group 200, and the IP will be what? 200.1. See that? So what I just did right now is I configured HSRP on router 1. This router is going to be the active router because I just ran the commands by default. So for gigabit 00, it says, hello, I am active, right? It's speaking active. And also for gigabit 01, it says, hello, I'm group number 200 and I'm also active. All right, nice. Then I want to go back to router 2 and I have to do the same commands. Interface gigabit 0/0. I do the same thing, standby 100. Then I put the IP command, and this is 100.1. Watch this. And then I go to interface gigabit 0/1, and I do the same thing, but group what? 200, and this is 200.1. See that? This router will be the standby router right now. Let's give it a moment. Let's do WR. See, now it's standby. Let's wait for the other standby to kick in. All right. Let's give it a moment and see what actually happens right now. There you go. So this router is a standby router. Let me save my configuration over here on this router, right? Because I don't think I actually saved my configuration after I did the standby commands. There we go. So if I do Control Z and I do show standby brief, I could see that this router is the what? The active router. We'll see what the priority is. There's preempt. We'll see what that is. But this route is the active. And if I go to this router over here, right, and I do show standby brief, it tells me this router is the standby router, right? See that? And who's the active, which is router 1, and these are the actual IPs. And it tells me what's the virtual number, the virtual IP address. Well, how does this work? I go ahead to the laptop and I give this number 100.100. 192.168.100.100. And look at this. What is the default gateway? 100.1, which is the virtual IP. It's either the IP of this router or this router, but right now, this is the active. This is the one that is taking effect. And let me give this an IP address, which is 200.100. And what is the virtual IP? 200.1, right? And then I'm going to close this out and close this out. So now if I talk from here to here, it should use this router, not this router over here. Well, first of all, can I reach, right? What's the IP of this? 200.100. Okay, let me open the command prompt, right? And do the following 200.100. The first packet is going to be lost. I mean, the reply from the ping is called what, folks? ICMP, Internet Control Message Protocol, which is the echo. See that? That's good. How about if I do a tracer space 192.168.200.100? What path does it take? Oh, it's going through the top router, 100.254, because that's the active. If I go over here and I open the command prompt and let's say ping, can I ping 100.100, which is a laptop? Yes, I could. Nice. How about if I do a trace search and see what path it takes? 100.100. And look, it's going through 200.254, which is this router right over here. I could also do it in simulation mode, right? So if I open the laptop and I open simulation mode and I say, can I try to ping and click on the play sign here? Let me move this on the side so you can see the envelope is going to go up this way, is going to reach the destination. So it's taking router one, right? That's the path that is taken. This is like basically a tracer, right? But I'm actually doing it through where? Through the simulation mode. So this is good. Okay, let me go back to real time itself. Well, let's test HSRP, folks. If I go ahead, first of all, to router one, the only commands that I did over here, if I do show standby in general, I could see that this router is the active router and what is the virtual IP. See that? Hello time is 3 seconds. What does that mean? We'll see what that is. We'll see what preemption is. We'll see what the priority is. The default is 100. And my gigabit 0/1 is also active. And the hello time is what? 3 seconds. Okay, well, let me go ahead to this machine and ping it with a negative T. All right, watch this. So this is a continuity ping, as you see. All right, well, how can I see if this router crashes? I need to, let's say, remove here and remove here. So router one crashed right now. I'm going to be losing connectivity for 3 seconds only. So count to three. One, two, and then three. And then I should get the reply back because the hello time is what, folks? 3 seconds. So you may lose connectivity for just 3 seconds. And then automatically the other router is going to kick in, right? Which is which router? There you go. It kicked in on its own. This router became the active. This one, it failed. The standby is like, hello, are you there? Within 3 seconds, no, I'm not there. Let me kick in and take over the role of the active router. So if I check here, oh, this router became active. And then, right, look at this. State is active, as you see, not standby like the way it was before. And if I do a tracer, let me just show you. Tracer, it's going through 100.253, which is this one. Okay, how about this one? All right, this is beautiful. 200.253, which is this one. Okay, how about we try the simulation mode over here? So I open this and I say, let me go through the actual simulation mode and I want to trace and I want to click on the play sign, right? And see. This is a trace. I mean, I could do trace or ping. I'm going to realize that it's going to take this route over here. See, it doesn't go there. I mean, trace is like, okay, there's no broadcast, but I'm taking that router. What I could actually do is I could actually stop this and do the ping, right? The ping itself and go back here and play it again. And you'll see now is going to be taking this path over here. Why? Because this is the active router. It's not the standby router anymore. See that? Okay, good. That's what I wanted to show you in this lecture. In our next lecture, we're going to see what is the priority? What is the preempt? What happens if this router kicks in? Is it going to fight for the role or not? All right, so we'll see you folks in our next lecture. Bye now. Welcome back. It's Mo again. Well, in this lecture, we're going to be continuing with HSRP, more configuration. Let me go back to real time. Watch this. I'm going to put this cable back. Okay. Gigabit 00 will go to this side, and gigabit 01 will go to this side. Will this router fight for the role? Will this router become active because this router is the active one right now? Let me fast forward and let me take a look and see. So look, this router became what? Standby. You see that? Now, if I do the following command, show standby brief, this is the standby. And this router over here is the actual active one. Show standby brief. And I can see it's an active one. In a real environment, this is not going to happen. In the Cisco packet tracer, it is happening. Let me show you what we need to do. So I'm going to go back to my main router, which is router one, this router here. So I'm going to go to global configuration mode, interface gigabit 0/0, right? And I'm going to do the standby command 100, right? And look what I'm going to do over here. The priority, the higher, the better. So by default, the priority is what? 100. Where do I see that? Let me get rid of this. Go standby, enter. So look at the priority. The priority, of course, the group is 100 and the hello time is 3 seconds, but the priority is 100. That's the default. They're actually the same right now. I need to make one higher than the other. So I'm going to go ahead and change this one over here, gigabit 0/0, right, to a higher number than 100. So I'm going to make this. I don't want to use the default configuration. So I'm going to say standby the group number, which is the same, 100. And then priority, look at this, and put a question mark. I'm going to make this one 120. All right. And space question mark. Carriage return, that means I could press enter. Then I'm going to do the standby command, the actual what? Preempt command. What is preempt? Overthrow the lower priority active router. So let's say this one has what? 120. Other router also has, let's say, 110. By default, one router is 120, the second router is 110. If they're both up, the one with the 120 will become active. But then let's say the active fails, the one with the 110 becomes active. And by default, the one with the 120 is not going to win the election unless I do the preempt, which means fight for your role. This is like in a real environment. On the Cisco packet tracer, you will not see much of a difference. So I only do the preempt on the one that I always wanted to be what? All right. And then I go to my other interface gigabit 0/1, and I do the same thing. The priority is going to be also what? 120. And I'm going to do the preempt command. There you go. So let me just save my configuration and look at my configuration. Show run. Now let's take a look and see the HSRP. So this one has a virtual IP, right? Right, see that? 100.1, 200.1, but look at the priority is 120. Did I change the priority over here on interface gigabit 01? No, I did not. Okay, so let me go back to interface gigabit 01, right? Interface gigabit 01, and I'm going to do the same command. The priority, which is going to be what? This is 200, and this is going to be 120. Let me save and do the run again. So right now I can see that the priority is actually 120 for both interfaces, and I have the preempt. I don't do anything on the other router, which means this is how it's actually done in a real environment, which means this router fails, the standby kicks in. Okay, how about if this router gets back online without the preempt, without changing the priority? This one will not kick in unless we do the preempt command, and I have to give it a higher priority. All right. So now when I do show standby, enter, I could see that the priority is this, and I could see that I do have, as you see, the group is 100, and this is a group as 200, right? And of course, the hello time is 3 seconds, right? So if I like to do the brief actual command, which is better, it shows me more in details like lesser priority, the group number, as you see, what is the virtual IP. This is how it should be actually done. Let me save my configuration. So in other words, this router kicks in, becomes active because this router failed, right? So this one becomes the active. If this one gets online, this one should be active because I have the preempt on and it has a higher priority. Okay, so that's how it should be done in a real environment. All right, so we'll see you folks in our next lecture. Bye now.